Sir, we can't hear anything. Excuse me, sir. You're not audible, sir. Not able to hear anything, ma'am.
ನಿನ್ ಮೈಕ್ ಆನ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಕೇಳ್ತಿತ್ತು.
ಮೈಕ್ ಆನ್ ಮಾಡಿದ್ದೀನಿ, ಸ್ಪೀಕರ್ ಆನ್ ಮಾಡಿದ್ದೀನಿ.
ಇವಾಗ ಏನ್ ಮಾಡ್ತಿದ್ಯಾ? ಅಸೈನ್ಮೆಂಟ್ ಯಾವ್ದು ಬರೀತಾ ಇದೀಯಾ?
ಯಾರಿಗೂ ಕೇಳ್ತಿಲ್ಲ.
ಯಾವ್ದಪ್ಪ?
ಯಾರಿಗೂ ಕೇಳ್ತಾ ಇಲ್ಲ.
ನಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಕೊಟ್ಬಿಟ್ಟವ್ರೆ. ಏನು ಕೇಳಿಸ್ತಾನೆ ಇಲ್ಲ ನಾನು.
Hello, ma'am. Can't hear. Think it's not 11:30 को पका दो रोटी गए और 12 बजे और स्टार्ट कर देंगे
खूप जरा झालं तर घेऊन तो देखील खायला किती दम पुरा भरपूर
You are able to hear?
Hello.
You are able to hear?
Yes, ma'am.
Hello.
Yes, ma'am.
Here now.
Yeah, now
Yes,
you're
ma'am.
able.
Yes, ma'am. It's clear.
You could have told I was muting. No, you could have told that. No. Okay,
Put
no
your hand
problem.
up.
I will mute.
Okay, sir.
I will mute everyone now. I will mute. Oh, hello.
Ma'am.
I will mute all of you.
Ma'am.
Yes, ma'am. Yes, ma'am. Sure.
Hear me or not?
Yeah. Now, ma'am. Now you're able to hear.
Okay. Okay, ma. Yeah. Now I'll just repeat whatever we discussed so far because the audio was not proper earlier. So we started discussing different types of a memory. One is ROM and another one is RAM. So ROM we have seen in the previous class. ROM read-only memory. There are different types of a ROM we have seen. How the erasing happens there. How the like EEPROM. How the programming happen. We have seen. Now we have a another type of a memory called as RAM, random access memory. So in a random access memory, we have that we can perform a read write, both the operation we can perform in the random access memory. We can read as well as we can write into that. Now in the random access memory, we have three types of random access memory. We have one is static RAM, another one is dynamic RAM, another one is non-volatile RAM. Three different types of the RAM memory is there. One more thing is when power is turned off, your content which is present in the RAM will be erased. So RAM is volatile in the nature. So again they're raising hands. What is happening? I don't understand. Abhishek Gada, I'm unmuting. You tell me what is the reason you raised the hand. Why is not here? You're not able to hear? Hello.
I can hear.
We can hear,
Hey,
ma'am.
please don't raise the hand in between here.
I didn't raise no, ma'am.
Ma'am, we can hear.
You can hear or not?
I can hear.
Yeah.
Yes, ma'am, we can hear it.
But why people don't raise the hand in between? I'll give permission at the 10 last 10-15 minutes. That time you can raising hand. No, I have to stop and ask what is happening. You are able to hear?
Yes, ma'am.
So others can keep you can mute yourself. All of you can mute yourself. Everybody can mute themselves, please. Shall I start? Start.
Yes, ma'am.
And then in a static RAM, actually we use a 6 transistor. In that 4 transistors are used as a latch to store the bit value 1 or 0, and the transistor Q5 and Q6 act as a word line. This particular word line will be made B, like you have B and B slash B dash, or we can call it as B and B dash. And you have 2 transistor Q5 and Q6, one act as a B and one more act as a B dash. And then by using this word line, we can either store 1 or 0 in the latch. And actually this is it is used because one cell itself uses more number of transistors. We are using the cost of this particular type of a RAM is more compared to other type, and it can store only its low capacity. We cannot have a more storage unit in this. And Janardhan uncle. Hello. You are audible or not here?
Yes, ma'am, it is audible.
Yes, ma'am.
Somebody has called is not audible.
Now it's audible, ma'am. We are able
Now
to
it
hear.
is audible. No,
Yeah,
now
yeah.
it's no issue.
No, ma'am.
Okay. I'm giving a permission to unmute by yourself. If you are not able to listen, no, like you can unmute yourself and you can give the suggestions. And we have two signal lines B and B dash, which is connected with the transistor Q5 and Q6. And whenever you have made one that like you want to store one in the latch, you can have B equal to 1, and then B slash is equal to 0. Whenever you want to store 0, you can have B equal to 0 and B slash is equal to 1. And one more type of RAM we have is DRAM, dynamic RAM, which uses MOSFET as well as capacitance for the storage. Because we are using a capacitance, there are chances of leakages in the data. So the charge we are storing in the form of charge, there are charge may get leaked periodically, we have to refresh the information present in the DRAM cell. So there are difference between DRAM and SRAM cell is an important small questions, and so like 4 marks they may ask. So you should you know that SRAM is made up of 6 MOS transistor and DRAM is made up of MOSFET and capacitance. DRAM cell needs refreshing, SRAM cell does not require refreshing, and SRAM cell is low capacity and more expensive. DRAM cell is high capacity and less expensive. And the operation wise, if you see, SRAM cell is more faster, and then your DRAM cell is it's slow in operation because of it needs a it needs your refreshing circuits. So then Nvram, where you have a battery backup and you can use your battery, because your battery backup is available. Your Nvram is like non-volatile memory. So a chip and your it comes along with the battery backup. So you can like whatever you stored no, and a power goes also, you can have the data in the Nvram cell. So these are the 3 types of RAM memory. And then we have next we have is we have to use the memory according to type of interface, whether it's a serial interface or parallel interface. Based on that, we can go with choosing the memory interface protocols. So serial interface, it uses I2C and SPI, whereas parallel interfaces, it uses 8-bit data lines for transmitting the data. And so like we have different memory structures. Atmel Corporation's AT24C5512 is an example of serial memory. So you can either go for serial memory or parallel memory. Now we have concept called as memory shadowing. So memory shadowing in the sense, here you people know that your current, that whenever a system restarts, no, the first program which need to be executed will be available in the ROM. So your ROM execution is very slow compared to your RAM, random access memory. So RAM is faster and ROM than ROM. So because of this, your bias programs mean basic input output system configurations. So in the bias calls are stored in the ROM. So initially when the system is booted, no, first the data present in the ROM has to be uh, brought to that, like your program is available in ROM, that ROM has to be booted. But the time taken to read from the ROM is more compared to the time taken to read from the RAM. So what happens is, when we are like when we are working with when we are working with the ROM, it takes time for booting. So what we are doing is, the content of RAM is available whenever, instead of we are using it for, basically we are not going to directly boot from RAM, the content will be copied in the RAM. So this is called as memory shadowing. So what are the details are required for booting process? That will be that booting process details may be basic port lines and plug and play devices details. All these are available in BIOS. So that information is needed during system boot. This configuration detail directly read by your system boot process, it takes more time. So instead of reading from the RAM, we are storing it ROM, we are storing it in RAM. So what happens is, now booting can take from RAM instead of ROM. Because of that, what happens is, it increases the system's performance, it increases the system performance. This concept is called as memory shadowing. So RAM we are not storing, actually RAM we are not storing because it's a volatile in nature. So the system configuration will be available in ROM only, read only memory. So whenever like the data which is stored in a ROM, if you are taking it directly like from the ROM, it takes a time. So before booting, the content of a ROM is copied in RAM. So this concept is called as memory shadowing. You are clear with this? Clear with this? Yeah, if people somebody
Yes,
can, like
ma'am.
you can. Oh yes. So this is, they may ask short notes, what is memory shadowing?
Okay.
Okay. And then there are different cases for choosing your memory for embedded application. So the memory selection for embedded application, there are 5 different cases we have. When to go for which type of a memory, what are the scenarios we have to consider for selection of memory for embedded system. So you know that embedded system need a program for storing algorithm, sometimes the operating system, and sometimes the application which is running on the OS and your variables and some lookup table information. All this need to be available in embedded system. So memory requirement depends on what type of application we are using. There is no standard rule that you have to follow the same thing. So here, case 1, whenever your embedded application system is working with SoC, okay, if it's like you need a complete on your application should be available in on chip memory, and then this is like completely SoC. It's a very small electronic toys and all based on SoC, where your on chip memory itself is sufficient, no need of extra memory. And next we have smartphone device, a second type of a thing where we have a smartphone device, and which need a mobile operating system. And then this is the example of a device where we can have a mobile operating system along with your embedded application. Now for running for running a such type of OS in your embedded application, we need 64 megabytes of RAM and 128 megabytes of ROM. So whenever you need extra memory for storing user application, we have to consider user applications and what are the thing they may be needed in the future. All this we should consider, and according to that we have to choose their memory requirements for a devices where your operating systems are available. And when you see memory, it comes under standard sizes. It will not come in a whatever the size we want. So there are standard size of memories are there. Most of the time the memory size, if you take note, it comes in two powers. It will not come like it will be 512 bytes, and then 1024 bytes, 2040 like 2048 bytes, 4 kilobytes, 8 kilobytes, 16 kilobytes, 1 MB. Like this only the memory requirement will come. We will not have a memory requirement accordingly. However, how much ever we want now, that chip we will not be getting. So for example, our system requirement is 750 bytes. 750 bytes means we have to choose the nearer boundary. So 512 we can't choose because 512 is lesser than 750. We have to choose the memory 1024 bytes. If our memory requirements, when we calculate the memory requirements for a given application by using all the possibilities of data and program, everything, if we consider how much memory is needed, we have to calculate that memory requirement is coming as 750 bytes. Then 750 bytes chip will not be available in market. What we should do is we should choose which is closer to it, more than it. So 750 bytes closer to it and more than it is 1024 bytes. We have to choose the memory where we like for our application we have to choose the memory 1024 bytes. So the memory chip will come in a standard size only. That standard size will be in terms of 2 power. So 2 power 9 is 512 bytes, 2 power 10 is 1024 bytes, 2040, that 2 kilobytes. 2 kilobyte means 2000, 2 power 11, and then 2 power 12 is 4 kilobyte. It comes in terms of 2 powers only. So your memory will come in the standard size. So whenever we like whenever we choose a chip, no, we should choose a chip which is very closer to our requirement, that more than that. And one more thing is we have to choose a memory based on addressing capacity of a processor. For example, our processor has 16 address lines. Then we should choose a memory 2 power 16, that is 64 KB memory only. We can up to 64 KB memory only we can address. Now my processor is having 16 bit. I can't choose a memory which is 1 megabyte, 1 MB. 1 MB means 20 bit address lines are required. So my address lines are 16 bit. I can choose the memory 64 KB. I can't go for the memory which is more than that. And then one more case 5 is your flash memory is a popular choice for ROM in embedded application. It is most powerful and effective solid storage devices. So there are totally 5 different cases we have seen for memory selection in embedded application. So first case, embedded system which comes on with the SoC. SoC means system on chip. So whenever your data completely it is available in a single chip, so on chip memory is enough for that. We don't require extra memory. And sometimes whenever your embedded application comes with operating system, we may be requiring memory requirement may be 64 MB RAM and 128 MB ROM, and then memory may be coming in the standard size. So whenever we have to calculate the total size of your memory requirement, based on the total size we should choose either like we have to choose either greater than or equal to the given memory requirement. So it comes in the standard size in terms of 2 powers, and depending on the processor addressing capability we should choose the memory. So processor is having only 20 address line, we cannot have a memory which address up to 32-bit address line. So based on the processing capacity we should choose the address line. And flash memory is a popular choice for random ROM. So we can, whenever any whenever you want ROM usage in your embedded application, we can go for flash memory. So they will ask you to explain what how to select a memory for embedded application. That may be the question for this particular topic. So you have to explain all the 5 different cases, and you should tell that what for you're using memory in the embedded application: to store OS, to store the algorithm, to store the variables, to store the lookup tables. So these are all the reason why we need a memory for embedded application. So and then you have to tell that when your operating system is there, how much is required, and what are the chip sizes, how to choose the memory requirement based on the processor address line. And then you should tell about we can use a flash memory for the will be the better choice for embedded application. And you are clear with this? Please somebody can unmute and tell me so that I'll understand that you are able to hear me.
Yeah, ma'am.
Yes, ma'am.
No, thank you.
Yes, ma'am.
And then next we have sensors and actuators in embedded application. Sensors and actuators. So we have two things. One is sensor, another one is actuator. So sensor is a device which measures the physical properties which is surrounded us. For example, temperature. We can measure the humidity. You can measure the motion deduction and all. We can measure with the help of sensor. Sensor is it detects the physical property and records, and whatever it recorded information can be used by your embedded application. And for example, in smart running shoes, this which we discussed initially, the smart running shoes in this chapter, initially we discussed this. In that we have a sensor in between the cushion and magnet, which measure the distance between the cushion and the magnet. That is the use of the sensor. So then next you have in on another device in your embedded application is actuator. Actuator is a device which turns the given energy into the motion. If you are in IoT devices and all, actuators are a very important part. And then it's like actuator work as a your output device in the your shoes. No, your micro stepper motor actuator is used for adjusting the position of the cushion element. So that is done by micro stepper motor, which is available in the shoes. So actuator will convert the given energy into motion, that means movement. And sensor is to use to measure the physical property which is needed in the surrounding. So these are the two important devices which you have in embedded application. And then next we have IO subsystem, input output devices available in embedded application. Input output devices available in embedded application. So in input output devices, already we are using in our lab, we have using LEDs, and we are using 7 segments, we are using stepper motor, all are input output devices. So we know the concept how that works through the program, how we are controlling. But here as a part of a theory, they will ask you to explain about interfacing of stepper motor, interfacing of 7 segment, interfacing of LED. Here no need to write the program, we have to explain only the um, theoretical part, how it works. Now first one is LED, light emitting diode, LED. So LED is a very basic output device. We are using LED for showing some indications. LED, for example, you are designing some your embedded application or IoT device, that is intruder detection system. in your home. So what happens is, whenever the person like there's a person's movement is happening near the device, it's going to give an indication. That indication we can use some LEDs, so that LED will glow and show that some movement has occurred. So LED is a very basic output device. It is used for showing some working of any particular device. We can use it LED. So LED we cannot have show complete output in an LED, but we can use an LED for the purpose of small indications. Okay, now we are pressing one switch. So the switch whatever you are pressing, no, that indication you can show in the LED, stating that the switch is like your user has press the switch. And if you take an LED, you have two part in that. One is cathode, another one is anode. So if you, I think if people have used LED for your first year projects, so you would have seen the LEDs. Everybody has seen the LED as individually LEDs you have seen without connecting.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am.
In that you have one is lengthy,
Long length.
The other one is
Negative and negative.
short. So short
Yeah.
one you can consider as a negative, and we'll
Long
put in a
one
ground, and then
positive.
the lengthy one will connect to the positive
Positive.
terminal. So you can give the lengthy one, you can call anode. We can give it to positive terminal, and then so smaller one we can call it as cathode. We can negative. So this is how your LED will look. Your LED, the shorter one is ground, and lengthy one is given to VCC. So again, you have to know that what is the flow of current, maximum current, 3.3 volts and sometimes 5 volts. It depends on what type of LED. So that particular volt you should give. So you can so one LED, if you want to glow, make it glow through the small breadboard, you want to connect that. Without program, you want to make that LED to work. So what we can do is 3.5 volts, we can give it to the, depends on VCC value, you can give it to the lengthy, and one more you can give it to ground connection, so that your LED will be working. So LED sometimes we can there are two ways we can make your LED interfaces. So you can connect to the anode directly the port pin of means GPIO pins. So GPIO, general purpose input output, you can use that GPIO, any one of the port you can use, P0.0, P0.1. And then what we can do is you can set P0.1 IO 0 set or something you can use, and then you can make the LED glow. So if you want that LED to be off, you can use the IO clear, and then you can make the LED off. So that we are done the programs, and then but we are not externally connecting the LEDs by using your breadboard, but that is already the connections and all, they are already done in your evaluation board. But we have small codes we can run, and you can make that LED glow and off. But the same thing, no, you people are taking your ARM LPC2148 separate chip. If you are taking, then you can make your LED to connect to one of the port, and then you can make it glow by using the program. And your port pin act as a source and give the current to the LED whenever the port pin is set to the logic high. So we use IO set, no, IO set 1 means logic high will go to the LED port, and then your LED will start glowing. Okay, another way what we can do is, instead of connecting anode to the port pin, we can connect cathode to the port pin. Okay, so this is a reverse way we can connect. In this way, your port pin act as a sink. Their port pin acted as a source where it was giving a current to the LED. Whereas here, when we are using a anode to the, sorry, cathode to the connected to the port pin, anode to the supply voltage, what happens is your port pin act as a sink. When LED will be turned on whenever the logic, whenever it is logic 0. So in the previous case, when you connect anode to the port pin, that time your port pin act as a source, your LED will glow when you are making it as 1. Whenever you are using a connecting cathode of your LED to the port pin, the port act as a sink. That means the data, your one more part will be connected to the VCC. Then the data sync means whenever logic 0, the LED will be turned on. So you can connect anode or cathode to the port pin. So when its anode is connected, it is a source. It gives it glows whenever logic 1. When you are using cathode to the port pin, it will glow when logic is 0. It depends on what type of interfacing is used. We can program our LED interface. So our case, no, always we are setting the LED glow only by making it 1 only. So that means our LEDs which are used in your ARM evaluation board, it is anode is connected to the port pin, not a cathode. I think most of the code we have seen, no, people as a beginning we had 8-bit 8 LEDs making glow program. You remember 8 LED glow program? First one we did, no? Very
Yes,
initially we
ma'am.
did
Yes, ma'am.
8 LED. So we made set IO set 111, IO clear, IO set 111 we did. That means 1 was sending. That indicates that all the LEDs which are connected to the port was connected through the anode, not with the cathode. That 8 LEDs. If it is connected at the cathode, no, instead of setting 1, no, we would have set to 0. Clear? For LED glow, we would have made it 0. For LED like off, on, we would have made 0. Off, we would have made 1. So that's why I'm telling it. Our LED connections in your board in a lab is anode is directly connected to the port instead of cathode. Clear? How the LEDs interface? It's a very simple, basic device. We don't have more complicated pins in this. We have only 2 pins. One is ground, another one is anode. That is your anode and cathode. So if an LED has to glow, means to the anode you should get a power. Okay, and your one more pin should be set to ground. Then your LED will glow. So it's very basic interfaces. You can easily control that with your program also. You can make it 1 and you can make it 0 also. Clear? So LED interface, you are clear? LED interface is clear?
Yes, ma'am.
Then next 7 segment LED display, which is already we are done in the program. So it may not be difficult for you to understand. Okay. This diagram, I think you people have seen this diagram, which we
Yes,
had drawn
ma'am.
in the so you have 8 LEDs together designed for 7 segment LED display, and it is used for displaying alphanumeric characters and 1 decimal point also. So how this design, how to derive the data from this is explained here. This, if you want to display 4 in this, for FGB or should be lit means it should become 1. And we can configure in 2 mode, anode mode and cathode mode. So anode mode means a common anode, common cathode. So your positive is connected all the in LEDs. You have 2 things, no, one is anode, another one is cathode. So all the anode are connected to only one point, then it will become common anode, and then common anode, and then cathode part is separately connected. Or else what we can have is one more connection is all the common cathode will be connected to single point, and anode like one single common point would have connected, and your anode would have connected to separate VCC. This 2 way we can configure. Depends on the configuration, 1 or 0 will vary. Common anode and common cathode, 1 or 0 will vary. Ours is common anode only. And then this, anyhow, the programs we don't have, we just have to tell about what is 7 segment interface. Clear? Clear?
Yes, ma'am.
Next we have stepper motor interface, which you already know. Stepper motor also. Okay, it's a stepper motor is a electromechanical device. It generates a displacement, discrete displacement, not a continuous displacement. Why you are calling it as a discrete displacement means for each signal, electrical signal, discrete displacement, step by step. So continuously it will not rotate. If you am giving some 10 pulses, 10 steps it is rotating. So that because it's steps, no 10 you can count. So countable means it is a discrete displacement. If it's non-countable means it's continuous displacement. And already I told in the class, your stepper motors are used in robotics and robot arm movements and all. We are using a stepper motor. And embedded applications, we use a stepper motor. Printers, we use a stepper motor. So stepper motor is a device which generates a discrete displacement based on the signals which it receives. There are two types of a stepper motor based for winding arrangement: unipolar and bipolar. Uh, Unipolar and bipolar, two different types of a stepper motors windings we have. So in a unipolar stepper motor, you have here you have two windings for one phase. You are considering it as two phase. In the two phase, we are using a two windings per phase. Then it is a unipolar stepper motor. And direction of stepper motor is determined by the current flow. The current flow, in which direction it happens, ABCD coil current flow happens, or DCBA coil current happens. Based on that, you can alter the flow of your your rotation direction, we can decide. And then in unipolar stepper motor, two winding per phase. And then in a bipolar stepper motor, we are having like this. In a bipolar stepper motor, it will be like this. Individually one winding for one phase, then it's a bipolar stepper motor. So we have separate winding for all the phases. And then we have different way we can rotate energize your stepper motor coils. uh, Based on this, we have three different way: full step, and then wave step, and off step. So you can see this how it happens in full step, wave step, and off step. In full step, mode, coil ABCD is energized in the following order. So one by one. So you just see here in a full step. Uh, high, L indicates low, H indicates high, L indicates low. In this coil A and B in a full step, at a time two coils are energized. And see, you can see that AB is energized. Then A is becoming low, BC is energized. Then A and B is becoming low, C and D is energized. Then C is becoming low, D and A is energized. In full stepper motor, there are totally there are four coils are present. In that four coils, A, B, C, D, four coils, we at a time two coils are energized in alternative order. So coil A and B is becoming high. Then coil C and D will become low. Then B and C will become high, and D and A will become low. That order, no, you can see this. This moves like this: HH, then next B and C HH, then next C and D HS, then D and A HS. This is a full step. Full step, at a time two coils are getting energized in full stepper mode. In wave step, what happens is, at a time only one coil is getting energized. Wave step, only one phase is, that is means only one coil at a time is getting energized. Coil A is energized, then coil B is energized, coil C is energized, coil H is energized. And then in off step, what happens is, in off step mode, first it uses the combination of both wave step and full step. So first, no, according to wave step, coil A is energized. Then according to full step, coil A and B is energized. Then according to wave step, coil B is energized. Again, according to full step, B and C is energized. So this eight different steps are shown here. That 8 different step is combination of these two, your combination of this 4 and this 4. Combination of your full step and wave step. Full step one line will come, sorry, first wave step one line will come, then full step one line will come, then wave step second line will come, full step second line will come. So wave step third line will come, then full step third line will come. You just see the bit pattern of your off step stepper motor. It uses the combination of both full step and wave step, but it has a highest stability compared to this. And then here no, you just see this according to your off step, H is energy, like your wave step, H coil A is energized. Then according to full step, A and B is energized. Then according to your wave step, B is energized. Then B and C is energized. C is energized. C and D is energized. D is energized. D and A is energized. Then this will repeat how many steps you have specified. So you have this tablers, you are clear how the table is generated. You are
Yes,
clear
ma'am.
with this
Yes, ma'am.
half step, wave step and full step.
Yes, ma'am.
Yes, ma'am.
You if you are not, you can, if you are not understanding, you can ask.
Understood, ma'am.
So there are three like we have working of a stepper motor, two different types of stepper motor we have. One is unipolar and another one is bipolar. Unipolar, we use one phase, use two windings, whereas in bipolar, for each phase single windings we are using here. And then mode of operations, if you take, we have full step, wave step, off step. In full step, one coils are energized, each coils are energized one by one. In wave step, sorry, in wave step, single coils are energized one time. Full step, two coils at a time. So the energizing way, if you see, A and B is energized. You can see here, A and B is energized. A and B is energized. So then B and C is energized. Then C and D is energized. Then D and A is energized. This is your what mode? It is your full step mode. In a wave step, if you see, individually one coil at a time is energized. Coil A, coil B, coil C and coil D. In off step, both the combination. First it follows wave step, the next step it follows full step. Wave step and full step. So these two together combination will come totally 8 steps, 8 different patterns will come in the off step mode. So this is how your 3 different types of a step work. So this is your diagram for stepper motor interfaces. So microcontroller, and then this is a driver which is used for stepper motor interface in that, and then 4 coils, 1 2 3, these 4 coils are connected to your microcontroller board, and you have VCC, and then here ground we have. So you people have connected your stepper motor to the arm evaluation board. Totally how many pins we have in that slot? A stepper motor will come with one wire, no? In that how many pins we have totally? You remember? For DC motor, you would have seen the relay meter, only 2 slots comes. Whereas in stepper motor, one white color cable with a slot is attached to the stepper motor, which you are connecting to the board. So in that, how many slots we have? Totally 5 slots we have. 4 for 4 different coil, 1 for your ground. You people see, remember that?
Yes, ma'am. Yes,
So this in theory they'll ask you to write, explain the stepper motor interfaces. You should tell how the stepper motor is arranged, unipolar and bipolar. This will come for 10 marks, these questions. Explain the stepper motor interface. Sir, from the interface we have LED, 7 segment, and then we have stepper motor and keypad. 4 different interfaces we have. But LED and all, they will not ask us much, because LEDs and all, like, they may not ask for a lengthy question. It may come for small, because LED anode and cathode connection only. Even 7 segment also they will not come. Whereas stepper motor and if you take stepper motor and keypad, these interfaces for 8-10 marks they will ask these questions. 10 marks questions it will come stepper motor as well as keypad. So here you have to draw the diagram and you have to explain how the stepper motor coils are energized, what are the two different types of a stepper motor, and this finally this diagram you should explain. You should draw this diagram for stepper motor. And here no you have LN283 driver circuits we have. So sometimes no the voltage is more volt 5 volt stepper motor means driver circuit is not required. When your stepper motor is having more voltage no it needs a driver circuit. So the driver circuit name circuit chip is LN2803. And this circuits no you have ST Microelectronics, on semiconductors, these are all the companies which manufactures this driver circuit. And this driver circuit is basically, if you see, it is built by using transistor only. And then your embedded application, two-phase stepper motors are popular choice. We can use it for uh, like in embedded application. And current requirement is not sufficient to drive the whatever the from the port, whatever the current you get no from the port pin, that is not sufficient to drive the stepper motor. To drive the stepper motor we need extra power. For that only driver circuits are used. So this is about a stepper motor. And next is your keyboard interface. Keyboard interface. So this is when keyboard interface program I explained in the class, I had drawn roughly this diagram. We have rows and we have column, and I said then closure circuits are there, where whenever key press, this circuits get closed. And this are your rows and columns are connected to your microcontroller processor port. Row is your output device, column is input device. So this diagram you should draw. So to drive each line no you are using 4.7 k ohm resistors, all are connected to drive the columns. Whenever you push no this that whatever the circuitry through the VCC, you are making the column lines to become high. That big column lines are read through the port. So we are arranging the keys in the matrix fashion. The reason already I told. So we have totally 16 keys here. Now here the reason is given. So you have 16, for example, interfacing 16 keys, no, we need 16 ports. So that 16 ports that 16 ports that 16 ports no it's very difficult for us to use all the 16 ports, because totally we have 16 plus 16 plus 16 totally 32 plus 48 ports only pins we have. All the 16 keys are connected to individually port pins no we are end up with shortage of port pins. So if you use a matrix format no only 8 ports are enough. So because 4 ports for 4 pins for your rows, 4 port pins for your columns. So this already I told in the class why we are going for matrix type. And keys are arranged in the matrix fashion. For deduction of key, it uses scanning process. In a program I explained scan method. And then each rows are low, and whenever each rows are set to low, and then column status are your column are red, rows are you will make your rows enable, and then you'll read the value from that particular column. So there are two way we can have push button switch, and we can have push to make and push to break switches configuration. We'll come to this later. Now I will leave you people for your discussion. Any doubts earlier what we discussed? So keyboard I just told matrix format, till that I'll stop. Push to make, push to break, what is that configuration? We'll come to this later. And today in today's sessions no we discussed memory type. Last class we stopped with ROM, read only memory. Here we have discussed RAM, random access memory. As you people know, read only memory is only we cannot modify the content present in the read only memory. That's why we are going for RAM, random access memory. It's a read write. In that read write we had three different types of RAM. static RAM, dynamic RAM, non-volatile RAM. And static RAM was using 6 different transistors. In that 4 transistors are had as a latch, uh, and then 2 different transistors are used as a control lines, Q5 and Q6. That Q5 and Q6 you are naming it as B and B slash. Whenever B is 1 and B slash is 0, your status of your latch cell will be 1. Whenever B is 1 and B dash is 0, 1 is stored. When B is 0, B slash is 1, 0 is stored. So Q5 and Q6 is a control line. This diagram you should draw and you should explain your SRAM, static RAM. And for dynamic RAM, you should draw this diagram and you should explain dynamic RAM. You have to mention the you have to low cost, and then capacitance recharging periodically, that and all you should mention in DRAM. And different between SRAM and DRAM, you have to sometimes small question they will ask, different between SRAM and DRAM. And non-volatile RAM, which comes along with the battery backup, so that refreshing is not required. And then memory interfacing type, there are 2 types of memory interfacing: parallel interface and serial interface. Parallel interface is directly connecting your data line or data memory to your 8-bit data line. That means parallel interface means you are going to connect your memory to your memory chip to your processor. When you are connecting your memory chip to the processor, memory chip is 8-bit data line you have in memory chip, all the 8-bit directly connected to your D0 to D7 of your processor. This is a parallel interface. In a serial interface, it will not be like one bit at a time only you can transmit. When you are using serial interfaces, you should go for using a serial interfaces like I2C, SPA and all. And there are parallel interfaces memories, Atmel Corporation's memory, they're told like serial interface memory chip, they're told. So this is memory interfacing. And then we have something called as memory shadowing. In memory shadowing, the BIOS information and booting informations all are available in ROM, but reading a data from ROM, it is very slow. It takes 100 to 200 nanoseconds compared to the RAM access. RAM access is actually, if you see, it is very faster. So what we are doing is content which is present in the ROM is copied, shadowed. Shadowing means the same thing you are writing in the RAM. Now the data, your port details are available in RAM. So booting process will directly access from RAM. It will disable the ROM. ROM is disabled, the content are read from the RAM. So because of this, the booting process can be fast, increase the performance, system performance. This is called as memory shadowing. And we discussed about how to select a memory for embedded application. There are 5 different cases we have seen: case 1, case 2, case 3, and case 4, and case 5. So one is simple toys where you have on-chip memory is enough. Sometimes if you need a OS and all in your embedded application, we need external RAM and ROM. And then memory is coming in the standard size. It is not coming in the what is the user defined size. So whenever you need a memory of 750 bytes, we don't have 750 byte chips. We have to go for 1024 bytes. And we, depending on a processor only, we can assign the memory, interface the memory with the processor. We can't use a memory, we can't go for a memory which is higher than the processor capacity. So 16-bit processor means maximum 64 KB only the memory. 2 power 16, 2 power 16 is 64 KB. So lesser, like more than 64 to 64 KB memory chip, we cannot connect to the processor of having 16 address line. So the processor capacity we should consider when you are taking the interfacing with the memory with the processor. And flash memory can be used for ROM in embedded application. And then we have discussed about sensors and actuator. Sensors measures the physical quantity and like your temperature, motion, and humidity, all the which is all the physical property which is measurable in the environment, that is measured by your sensor. Then next is the actuator, which is going to convert the given energy into motion, that is mean movement. So actuators are used for any in Internet of Things. It is work as an output device that is used for making the movement of any other devices which is present. Micro stepper motor is an example which is used in your smart shoes. And your IO subsystem, we have seen LED, and we have seen a 7-segment LED display, and we have seen the stepper motor. So for keyboard, again once again we'll discuss keyboard from the beginning in next session. So 5 minutes of time you have. So if you can ask any like any part, you can ask doubts from this. Somebody asked for sending the notes. I will forward the notes in the groups today. Anything else? So this is most of the theory part only here. You people just notes if it is there with the what basic inputs I am giving, it will be more than sufficient to understand the topic. And most of them were discussed through the programs in the classes. And then memory, if you take memory and all, we had already studied in CO. So many things which you know already, and but in an organized way, you want to know what is there in the syllabus, exactly what you have to prepare, how the questions will come. That is a thing we have to concentrate now, not about the like most of the concepts are familiar to you. Now how the question organized way and how the questions will come, what to concentrate more in this particular chapter, like this you have to prepare now. So anything else need to be discussed? So you are clear with all these things what we discussed so far? If any part is not clear, you can tell me. Next session I'll start explaining that, and then I'll continue with the further topic. Clear?
Yes, ma'am.
One more thing, no, next Saturday Bhavana ma'am will be explaining how to use your Kale environment. And everybody have installed your Kale.
Yes, ma'am.
Yes, ma'am.
Everyone are able to open the window, Kale window.
Yes, ma'am.
Yes, ma'am.
Next session, no, you just have a laptop where you have a Kale. Parallelly, when after in a session, during a session or after a session, you can execute the programs. Ma'am will explain the software programs, what are available.
Okay, ma'am.
So next session Saturday, please don't miss the session. The labs, I'm labs again. The theory part of lab, like software part of a lab, will not be repeated once again. So don't miss the session. And parallelly, you have to execute the programs also in your Kale. Then only you'll understand it. Just listening to the discussion will not help you. You have to know how the things are working also. So sometimes now you need to know the how to see the output and all. So please, you parallelly if you work, no, you can understand better. So Saturday will be your lab session. And one more ADC I explained for B section, but still one more time I'll explain A, B, C together. So next week ADC will complete. So if I complete ADC, all the 8 programs hardware is completed. So once you come to the college, no, then you people can start working on the hardware, that pending program you complete, and then you can work with the software anyhow you would have completed in the your places only, because you have a software installed in your laptop. 8 programs, no, you can run your 8 programs on a single day. You can complete all the part A. So please make sure that everybody is installed your Kale. You are installed, everyone has installed. If anyone has issues in installing it, any issues in installing your Kale, so please you just download that and you install. It will not take much setting and all. Just download and install. Part A extra lab session will not be given once you come back to the college. Only hardware part you can execute. So part A you should execute in your laptops only. Clear?
Okay, ma'am.
Yeah, thank you. Notes notes today I'll send the notes. So somebody is telling they don't have a laptop in native. So you, I don't know, because we don't know when the situations will become better. So you should take it from somebody and you should execute. If anybody of your neighbors or relatives are having, no, you should execute here, because we can't wait until everything is fine. After that, if you see, there more number of days, they will not give it you also. So you should complete the things. Okay, thank you. Saturday ma'am will be discussing. Thank
Okay.
you all.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, ma'am.